Hello everyone. Now in section 11.7 we're going to look a little bit more about graphing quadratic functions. We just came out of section 11.7 where we learned how to graph quadratic functions that are in the HK form or the vertex form. In this section 11.7, we're going to focus on the polynomial form of quadratic functions, and we're going to see how we're going to graph these types of functions. Now, before we proceed, I actually want to show you a couple of pages of the exercises where we're going to be looking at problems very similar to your homework problems. The exercises for this section that we're going to be looking at start on page 747, and let me again scroll this down so you can actually see this segment beginning with exercise number 9. Here are the instructions to the exercise, and of course the balance of those are on top right through number 18. I believe your exercise for the homework is number 13 in this segment. And then in the following segment, the one directly below it, you're doing numbers 19 and you're doing number 23 for your homework. And on the following page, that would be on page 748, you're doing exercise number 39. So that would be this page. You're doing exercise number 39 in this segment. For all of these exercises, the way I'll work them like this one. That is, we're going to find the vertex, the axis of symmetry, that is the equation for the axis of symmetry, and the maximum or the minimum of the quadratic function. And of course, we will be graphing these as well. So with that, I'm going to go ahead and go to our notebook, and then we're going to get everything started here. Once I'm prepared, give me just a moment and I'll come right back. Okay, so I'm back. Let's actually take a look at section 11.7. Again, our focus is on the polynomial form of quadratic functions and how we're going to graph those. Now, in the polynomial form, as you can see here, if a, which is the coefficient on x squared, if a is positive, the parabola is going to open upward, and for a negative, the parabola will be opening downward. And remember, a cannot be 0, because if it's 0, again, we do not have a quadratic function. The function reduces to a linear function. Now, in this form, the y-intercept, that would be the point where the graph crosses out the y-axis, is going to be when x is 0. And you can clearly see that when x is 0, this term would be 0 because x is 0. And x0 makes the second term 0. So if both of these are 0, c, the constant c, is the only thing that remains. Therefore, the y-intercept is always going to be at point 0, c. And the axis of symmetry, its equation is going to be x equals to negative b divided by 2a. Again, these are the ABCs from the general quadratic function. So that would be the equation for the axis of symmetry. And finally, the coordinates of the vertex. I'm just bullet these key points. And to find the vertex, we actually have formulas for finding the vertex here. So the formula for the vertex, the x component of the vertex is negative b over 2a. No surprise, is the same as the equation for the axis of symmetry. Remember, this axis runs through the vertex, so it will have the same formula as negative b over 2a does. So the x component of the vertex, negative b over 2a, and there is a formula, by the way, for the y component of the vertex, but the easiest way, so you don't have to memorize yet another formula or deal with it, is to evaluate a function at negative b over 2a. That means whatever number you find in here for x, you just plug that in for the value of x in the function, and that would give you the coordinates of the vertex. Now, as we do this, never mind these, I'm going to move them. And we're going to actually be using these in a few minutes. So in order to graph these quadratic functions now that are in polynomial form, we need to have, so let me write this for you, to graph the parabola. Remember, the name of the graph is parabola. Parabola. To graph the parabola, we're going to need 3 points on the graph. In order to do this, we need 3 points. Now, one of the points must be a vertex, which is the turning point, right? We have to have the vertex, and we need to have 2 points. Okay, these 2 plus the vertex make up the 3 points that we need. These 2 points will be 1 on either side of the axis of symmetry. And what I mean by that is that on the branch, on each branch of the parabola. So that's pretty much that's what that means. Let me write that. By that I mean on each branch of parabola. The right side and another one on the left side. Okay, so that's what we need. Now let me kind of move all of these good stuff out of our site. We will be using these in a few minutes. I just want to get to them when we need to. So let me move them out of the way, and we actually look at our first example here in a moment. Okay, so let's take a look at, to begin with, we're going to look at exercise number 20 on page 743. Okay, in exercise number 20, the quadratic function f of x is equal to x squared plus 2x minus 5. Okay, and we want to graph this function. Now, the important information that we can glean from this, remember the coefficient on x squared here is 1. If it's not written, it's 1. Okay, so that's what that is. And let me tone down the intensity of my red pen. Okay, so here I'm going to write that for this function, a is 1, and then b is 2, and c, of course, negative 5. Now, the fact that a is 1, it is positive, so that just tells us the parabola opens upward. We know that much. Okay, now remember we need 3 points. So towards those 3 points, first I'm going to find the coordinates of the vertex. So I'm going to do negative b over 2a, and that's going to be negative 2 divided by 2 times 1, and that would be a negative 1. In order to find the y component of the vertex, now I need to do f at negative 1. Okay, so I'm plugging in negative 1 into the original function. Okay, I'm plugging negative 1 in for x here and in here. We are evaluating the function at negative 1. So this is going to be negative 1 squared, and then plus twice times negative 1 minus 5. If you do the arithmetic here, you should get negative 6. That's negative 1 squared is 1. 2 times negative 1 is negative 2. Negative 5 makes negative 7. And the 1 in front makes negative 6. And there we have it. The coordinates of the vertex is going to be x is negative 1, y is negative 6. So we have managed to find the vertex. And because the parabola opens upward, therefore the vertex is going to be the trough, or it's going to be the minimum value. Now, we need points on either branch of this parabola, right? So let's see how we're going to find those points. Well, one of the points that we want to find is right in here. This is c in the ax squared plus bx plus c. This is c. C is negative 5, and remember that's going to be our y-intercept. So the y-intercept, our y, let me fix this one. Our y-intercept is going to be at when x is 0, y is negative 5. There you go. And just to highlight it and you show just to show you that this is where it came from, directly from the function itself. Okay, so here's one point that we just found. Now I'm going to go ahead and bring up my Cartesian coordinate grid in here, and actually I'm going to graph these or plot these points. So remember, 1 point is going to be 0, -5, so that's this point right here. When x is 0, y is -5. So there's 1 point on the graph of the parabola. The other point was the vertex, right? The turning point. That would be -1, -6. So -1 and -6. This is where that point's going to be. So at this junction, I can actually draw the axis of symmetry, right? The axis of symmetry is going to be the line that runs through the vertex. So this is where the axis of symmetry is. Let me use green on that one. And there you go. That would be the axis of symmetry. Okay, now, so I've got the vertex. I have, here's my vertex again. We have 1 point on the graph. This point was 0, -5. And this was the vertex. And the minimum at this point, we know that the minimum is going to be -6, right? Always, if the parabola opens upward, the vertex is a minimum. Now, this third point that we want, what I like to do is actually use the reflection here. So let me, if I can enlarge this, let me enlarge it so you can see a little better actually these points. Oops. That's okay. I can just do this because I want you to see this a little bit better. So don't mind what I'm doing here. I'll put those back on in a moment for you. Remember the vertex was -1, -6, so this was the vertex. 0, -5 was the intercept, and of course I had this axis of symmetry, which is this vertical line, right? Now I can actually find this third point by reflecting this point, this 0, -5, this point right here. If I reflect it across the axis of symmetry, I'm going to get a point right in here. So that's in fact what I'm going to do. I'm just going to draw this other point here, and there's my third point. You see that? We got the key point you really need is the vertex, because otherwise it's not going to help me do this. And now that I have it, let me just kind of draw it, and there you go. We get draw this part, and we draw this other part, and here's the graph of that parabola. Okay. The points again that I selected were 0, -5, the y-intercept, and by reflection we get this point which is at -2, right? That's -2, so it's going to be -2, -5, and of course this was the vertex, the low point, and then we have the graph. Now I don't want to minimize this graph because then I'm going to lose these points. So what I've done is I actually graphed this on a software. I use Desmos. I'm sure some of you heard of that, desmos.com, and you can actually graph these. So I just want to show you a better graph of this perhaps, but I can actually annotate this one now. So here's where the vertex is, right? That's the vertex right here, -6 and -1. And of course this point is the one that I did. This was 0, -5, and I used a reflection to get this other point. This other point was -2, -5, and those are the 3 points that we drew the curve through. And there you have it. This is a complete answer to that exercise. So to recap again, the key items that we are interested in are the vertex. We need to have the vertex as one of the 3 points. The y-intercept is another important point, right? We want that one. We answered to the question, what is the minimum or the maximum? So we got this one, we got that one. The equation for the axis of symmetry, by the way, let me write that one also. Let me see, probably here. Our axis of symmetry. is going to have equation always x equals 2, and then what it equals to is the h portion in the vertex, the hk form, that is -1 right here where I have the vertex. X equals -1, that's going to be the equation. Remember, in the general form, these are the h and k, those two things. Okay, and that completes that exercise. Hope you followed this one, and you're okay with what we've done. And let me kind of brush up on that and make it look neater. Okay, so we're done with this one, and we're gonna do another one. This next exercise is exercise number 24, the one that we're about to do. Okay, so let me again move these out of our way. I did this ahead of time so we don't have to waste time going to Desmos, and so it doesn't make the lectures overly long, so you don't have to become bored with it. Okay, and there we have it. Now they're out of our way. Let's take a look at our next exercise. This one is going to be number 24 now. So in exercise number 24, this time our function h of x is going to equal to 2x squared plus 16x plus 23. Okay, so that's going to be the function. So right off the bat, we can identify the ABCs. A is 2, B is 16, and C is 23. The fact that A is 2, it is positive. That tells us this parabola is going to open upwards. Okay, so we have that figured out. Next, we're going to find the vertex. Okay, so vertex, call it h, right? I'm going to say with our hk, and let me shrink the font size, okay, on my pen, and otherwise it doesn't look as impressive. There you go. Sorry. Okay, so here, h is going to equal to negative b over 2a. Okay, we use x, h, doesn't matter, as long as we have an identifier for the vertex. So h is negative b over 2a. That means it's negative of 16 divided by twice times 2. That's going to make this negative 4. Okay, so we have that one. Now to find k, k is going to be equal to f at negative b over 2a. Okay, in other words, we're going to evaluate the function at negative b over 2a, and this time f at that point, I'm actually going to, well, let me write it one more step over here. So we're going to do f at, remember, negative b over 2a turned out to be negative 4 here. So we're going to do f at negative 4. That means I'm going to plug in negative 4 into the equation. So that's going to be 2 times negative 4 squared plus 16 times negative 4 plus 23. And I'm going to go ahead and use color to help you see the substitution a little easier and better, perhaps, to help you see that. Now, doing the arithmetic, negative 4 squared is 16 times 2, that would be 32. Negative 4 times 16 is negative 64 plus 23. And when you combine those, if I did the arithmetic right, I got negative 9 on this. So at this point, we actually have the coordinates of the vertex. So our vertex is going to be at hk, which means the vertex is going to be at negative 4 comma negative 9. Okay, so we got that key point. What other key information we have here so far? Okay, the parabola, of course, opens upward, right? That's important also. So that means we will have a minimum but no maximum, okay? Because it opens upward. So there is a trough, there is a low point, but there is no high point. And the high point goes to the sky forever. Okay, so we got the vertex, and now we are actually in a position to graph this one. So let's see. We need 3 points, right? Well, one of the points, again, I'm going to use is the y-intercept, which is when x is 0. So I'm going to take advantage of that, and let's write down our y-intercept. That would be the place where the graph crosses the y-axis. Our y-intercept is going to be at always x is 0 for the y-intercept. And the y is going to be 23 again. That comes from this highlighted number in the original function. Okay, that's where that comes from. Okay, so this would be our second point. Our third point we're going to get by reflection. Okay, we're going to reflect about the axis of symmetry. So now I'm going to have to, let me bring this one up. And let's see how this is going to fare. And of course, I have the Desmos graph that looks much better than the one I drew by hand. But let me just annotate this. This would be our x, and here is our y-axis. Now, because the y-intercept I have at 23, so I got to be careful how I'm going to choose my grid lines here. So each grid line, let's say, represents, I don't know, 4 points maybe. So this is going to be like 4, 8, so 23, 4 by 6. That's going to be, let's see, 4 by 6. So it's going to be here, 1, 2, 3, 4, 5, 6 times 4, 24. Again, each tick mark for me is 4 units. Okay, folks, 4 units. So this would be -4, that would be -8, -12, and so on. Okay, and this would be like 4, 8, 12, 16, 20, 24. Now, 0 and 23, it's going to be, let's see, 23, 0, it's going to be this point right there. Okay, and of course, -4, -9, this is -4, 4, 8, and -9 is roughly about here-ish. Okay, and then I'm gonna try to draw this parabola the best that I can. That will make it go through these 2 points, something like this. Again, I have a better drawing of this using the software. This is going to be a narrow excuse me, a narrow parabola because the coefficient in front of x squared was 2. Okay, now the axis of symmetry, of course, is going to be this line, right? That's going to be the axis of symmetry, whose equation we already know, right? The equation is x equals -4 for the axis of symmetry. So we got the trough, the low point, we got the intercept, and by reflection right here we get we get the second point on the other branch of the parabola, and then we can just draw this parabola, and there you go. It's gonna look again kind of skinny as it works its way through. So this would be the graph of this quadratic function. Again, there is no max. As you can see, the up arrow means this graph, both branches extend to positive infinity. This point, the key point that we found was 0, 23. And of course, this was the vertex that we found. And this point we got by reflection. So let's see, it was -4 to the right, reflected over. So this is going to be -8, 23, right? -4 on either side of the axis of symmetry. And there is the graph of this one. Pretty neat, huh? Now, let me move this up, and I'm going to actually now reduce it. Oh, perfect. So I was afraid if I reduce it that my graphs, the pen drawing, are going to move out of the way, but they didn't. Anyways, at this point, let's move this out of the way. And let's bring this one up. And here's what actually the graph looks like. Notice how narrow that graph is. Okay, and let me move these again out of the way so we can only focus on what's up here. There. Now, this axis of symmetry again for this parabola is going to be this line right in here. That's what the axis of symmetry is, that one. And that has equation x equals -4. The low point here, That's the vertex, which we found it to be -4, -9, and of course point 230 is up here somewhere. Okay, so it's actually right here. There we go. That is this point right there, the y-intercept. And the way we got the third point on the graph was by reflection, right? I reflected this point across, and this would be our other point. So these are 1, 2, and 3 points, the third point being the vertex, the key point. We definitely want the vertex. Okay, so hopefully you're okay with this exercise. Let me just kind of again bring it up to the beginning, and this is a synopsis of what we've done in exercise number 24, and hopefully you're okay with this one. Now, let me take a look at one more exercise, number 40. Okay, so we're going to take a look at number 40, and as you can see, I have already prepped for this exercise, so I'm kind of ready for it, which is a good thing. Let's do exercise number 40. So in exercise number 40 now, the function f of x is equal to -3x squared, -7x plus 2. And we want to do the same things again, same key components that we found in the other exercise. We want to do it for this. So let's start with our ABCs, right? A, B is, and C is. There you go. Those are our ABCs. We definitely want to start with them. Now, the next step, remember, we need to determine the fact that A is -3. Since -3 is less than 0, we know that this parabola is going to open downward, right? That's it. That's a good information to have. Okay, and we already know one point, right? Remember, this is the y-intercept. So that's what I'm going to write here. 0, 2, that we're going to make it our y-intercept. All right, so we got 1 point. Now, next, what do we need next? Of course, we need the vertex. So let me move this down, and we work towards the vertex now. The vertex, which is at HK, remember our H is given by, H is equal to -b over 2a. So I'm just going to write negative of -7 divided by twice a is -3. A lot of negatives in this one. Negative by negative is positive, and so the answer is going to be negative. Now 7/6, right? That's going to be -7/6, which is an improper fraction, or I can write it as -1 and 1/6, so I know how to go to my rectangular coordinate system, and I choose my grid according to that. Okay, so there we have that one. So what do we need next? Well, we have the h, we need the k, don't we? So here k is equal to, remember for k, you just evaluate the function at h, which is at, let me just put it here. There you go, at h. Or you can write -b over 2a, right, over here. This is what we need. So I need to go to the function actually to do this. The function is right up in front of exercise number 40. So I'm going to plug in -7/6, not the mixed number, but the improper fraction. So this is going to be -3 times that squared, -7 times -7/6 plus 2. And I'm going to put now -7/6 in here. Okay, that's -7/6, -7/6. That's what f at h means. Remember, h was -7/6. This is what h was, right? Okay. Now, I trust you can do the fractions, but just because fractions are always problematic, let me just kind of put the steps in here for you as for how I did this. So what we do next is the following. Equals -3. Now 7/6 squared, 7 squared 49, 6 squared 36, right? That's going to be 49/36. And then negative times negative, positive, 7 times 7 is 49, 6. we multiply 7 by 7 in the numerator, not the 6 in the denominator. I'm going to go ahead and write 2 as 2 over 1 in preparation for combining fractions, right? Because we're going to have some fractions to combine. They have to have the same denominator, otherwise they do not combine. Okay, and next, let's see. To simplify, well, I can simplify 3 and 36. That makes it 12, doesn't it? Okay, and let's see. What do I do next? Next, I'm going to write this as equals. So it's going to be negative 49 divided by 12. I can see the LCD, right? The LCD, that would be the least common multiple of the denominators. That is 12, 6, and 1. The least common multiple is going to be 12. Plus 49 over 6. Need to build that fraction. Plus 2 over 1. And I'm going to have to build this fraction also. True? I'm going to multiply this top bottom by 2 and this one by 12, right, to have the same common denominator for all of them. And I did. So next step, now I'm going to write the common denominator. There's your LCD of 12. We have negative 49 plus 98 plus 24. And all of this turns out to be 73 divided by 12. And 73/12, that's going to be 6 and 1/12. Now, of course, I have the computer-generated graph, but I'll try to graph this by hand, so just to go through the motions. But at this point, we have the coordinates of the vertex, folks, right? So our vertex is going to be at negative 7, 6, and 6 and 1/12. Okay. And remember, negative 7, 6, I have it up here. Negative 7, 6 is 1 and 1/6. True? So let's actually go ahead and try to graph this one now. Again, let me move the computer-generated graph out of the way and just bring this one up over and possibly enlarge it so we can actually graph it, and it looks halfway decent. And there you go. So we're getting ready for this. First, I'm going to plot these points. Now, negative 1 and 1/6. So this is going to be 1 and 1/6. Right in here, just to the left of negative 1. That's negative 1 and 1/6 right here, right? And then positive 6 and 1/12, right? Positive 6 and 1/12 is what we have here. So for positive 6 and 1/12, that's almost 6, call it 6. So we're right up here somewhere, right? Just barely above 6. So that's going to be the vertex. And remember, this parabola is going to open down. True? We have it right up here. We said it's going to open downward. And one of our points was the y-intercept in blue up here, 0, 2, right? That's what it's going to be. 0, 2. Let me put my comma down here so it doesn't look like a negative 2. So that's 0, 2. And we should be good. 0, 2, that's going to be right here, this point. 0, 2, this was the vertex. The parabola opens downward. The axis of symmetry is going to run through the vertex. So there you go. That's going to be the axis of symmetry. True? And this parabola is going to open downward, going through the point and right here. Again, I would just make sure it goes through that point, the key point there. That's the turning point. And by reflection, we get this other third point. Make your parabola go through it. And roughly, again, I have a better picture of this in a moment for you. I just want to show you how you go through the motions if you're doing it by hand, which almost all of you are. And here we have it. And that was our vertex. So our 3 points: vertex, the y-intercept, which happened to be, again, 0, 2. 0, 2, and then the reflection of it over here, whatever that turns out to be. remember we went to the left 7/6, so we just go another 7/6 units to the left. So that's going to be 2 times 7/6, which is 14/6. So it's 14/6 because you're doing 2 times 7/6 by the time you go to the left. And of course it's negative, right? We know that. And this can reduce to negative 7/3. And so that's what this point is. This point is going to be negative 7/3, comma 2. And I label them just so you see how they go. Unlike previous section, remember in previous section it was really easy because the quadratic function was in the vertex form. We quickly identify the vertex and we use transformations, right shift, left shift, up, down, reflections to do it. But in this section we just have to do it this way. And there you go. So this is the graph, and let me actually now bring the computer generated one kind of side by side, or if I can. Ew, there we go. Wow, not bad, folks, huh? Okay, so I'm just gonna slide it to the right a little bit here on its own self, and you pretty much see what we've done here. Now let's just label this one, not that we need to, but just to do. There you go, that's your vertex, just as before. This is 0, 2, the key point, right? 0, 2, and of course the reflection was here, the axis of symmetry that runs through the vertex. Let's see, it was the right, like that, right in here. Because of that fraction, 1/6 is hard to kind of do an accurate one. But anyhow, that's what that is, and this is our third point that we found. This point, we found it to be negative 7/3, comma 2. Exactly the same as the image on the left side, the graph on the left side. So hopefully again you're okay with this one. I want to emphasize we need 3 points, folks. Okay, 3 points. You need a vertex, and my other favorite point that I usually use is the y-intercept, this one right in here. That's the second point, and usually the third point, as you just saw, we get by reflection. Once I had the y-intercept, I reflected it across and we got this other point. So here's 1, 2, and that's your third point. Now let's finish this off by noting one thing. Okay, and what I want to mention now is this, and this is actually one of your exercises. I think it's exercise number 9 that you're doing. I'm sorry, no, exercise number 13. You're doing number 13. So this is kind of like number 13. Okay, in fact, I'm going to do number 14 with you, or for you. Now, it is possible to go from the polynomial form to the vertex form. So that's what we want to go. Okay, so this is what we're doing. We want to change from polynomial form, from polynomial to vertex, or also known the HK. Oops, my HK form. There you go, HK form. Okay, now we can do that by the following. In this exercise that we're about to do, exercise number 14, the function, so this is number 14. Let me erase that one and put it back on. In number 14, the function that we are looking at is, oops, sorry, not sure what happened here. There. In number 14, we have f of x is equal to, I guess I'm just touching stuff on the screen, that's why. So that's 2x squared negative 20x minus 3. Okay, so this is what we call the polynomial form. And the question asks us to write this in the vertex form. So here's how we need to do this. First, we need to group the x terms together. So that's 2x squared minus 20x. Okay, I'm going to group them together, minus 3. I'm literally moving 3, negative 3, brush it to the side. Now, next step, we need to complete the square in x. Remember the HK form, x minus h squared, that's the square of a binomial. So I need to create the square of a binomial here. So I'm going to first factor a 2 because when we complete the square, remember the prerequisite is that we have to have a 1 in front of x squared. That's in front of this term. It has to be a 1. Now it is because I factored the 2. Now, note I just factored the 2 from the x terms, right? The terms having x in them. The negative 3 is still active on the other side by itself. Okay, there you go. Now, next step, going through the procedure, the process of completing the square. If you recall, we need to add negative half of, let's see, not negative, but just half. We need to add half of negative 10 squared in order to create a perfect square trinomial. That's half of the coefficient on x. Remember that work? Now half of negative 10 would be negative 5. Negative 5 squared is going to be 25. Okay, so I'm going to, in red, I'm going to add 25 in parentheses. Now we got to be careful here because I just added 25, that red 25 that wasn't there a moment ago. Now, so I need to offset for what I've done. And here's what we need to do next. I'm going to actually, although inside parentheses, it looks like 25, which it is 25, by the way. But because of that 2 on the outside, you see this 2 on the outside, there is a forced distribution of 2 to number 25. 2 times 25 is 50, right? So even though it looks like I added 25 on this side in parentheses, but because of the 2 on the outside, it will distribute itself onto 25. So it's really, in truth, reality, I added 50 on that side. Now we can do two things, right? So remember, here's f of x every step. We just don't write it. So because I added 50, I can add 50 on this side, right? To maintain the equilibrium, the balance of the equation, right? Or if I do that, I need to isolate f of x. I'm going to have to turn around and subtract 50x from both sides, don't I? So I'm going to do that just in one step. I'm just going to subtract negative 50 from that side. Okay? And this way, I don't need it on this side. I don't have to do this on this side. So hopefully you follow that. Therefore, f of x is going to equal to 2 times. Now, because 25, the way it was added, the way that means half of negative 10 squared. We know that's a perfect square trinomial. So I'm going to write the binomial form of that, which is x minus half of 10, which is 5. X minus 5 squared, negative 53. That's negative 50 minus 3 combines to negative 53. And there you go. We have the HK form of this one, ladies and gentlemen. Here's minus x minus h. And of course, k here is going to be negative 53. That's what k is, negative 53. Okay. And a would be 2 here. And that's precisely what the question asks for. So you can see how we can go from polynomial to vertex form. It does involve completing the square method. Now, going the other way around, let me just make one up myself. Example. Let's say I'm given a function f of x is 3x minus 4 squared plus 7, just made up. And we want to rewrite this. We want to convert or change to convert to vertex form. Okay, the exercises, they don't have you doing this, but I'm doing it just to see how you can go both ways. Now, these are actually pretty easy to do. All you have to do is first expand the binomial. So you go x squared, negative twice first by second, that's negative 2 times 4 times x, plus negative 4 squared is 16, plus 7. And then distribute the 3, you get 3x squared, negative 24x, plus 48. My 4 doesn't look that great. Now it does. There you go. 48 plus 7. And this is going to make it 3x squared negative 24x. 48 and 7 makes 55, and there you have it. So this is now polynomial form, and that is exactly what we wanted to do. So it's good to be able to go back and forth between the two forms. And with that, we will conclude this section. I hope you followed everything we did. We did a lot of good work in section 11.7. So we're done with this section, everyone. I hope you enjoyed it and learned a lot. See you in another lecture.